All right, so for polar coordinates, really what you have to change is a little bit of a mindset. And what we've been used to graphing so far in everything since like pre-algebra is what we call rectangular coordinates. Rectangular coordinates, when you learn them, you set it up with the origin at 0, 0 in the middle. There's an x-axis side to side, a y-axis up and down, and your points came in the format x comma y, where x was the side-to-side distance and the y was the up and down distance. And that's what we really got used to graphing. Well, there's a whole different form of graphing called polar coordinates. Rather than being on an x, y, like square axis, polar coordinates are based off of the unit circle. Okay? So it only has one axis, which we call the polar axis. It's exactly where the 0 started for your angles. You know, we started over on where the positive x-axis was and went counterclockwise. When you do a polar point, rather than it being an x and a y, it's an r comma theta rather than an x comma y. Where r is the distance from the pole, what I compare r to is like the radius of a circle. So since it's a circular graph, the radius is how far you're going to go out. The angle is the angle in standard position. The other big difference is, and I'll just give you an example here. If I graphed a point on the xy plane, there's only one way to name that point. And I just did a very basic graph there, but how would you name that point? 2, 2. There is no other option for that. It is 2, 2. There is nothing else you can say. When we do polar graphing, you have many polar coordinates for each single point. Okay, so you're going to see that on the next page where we start doing some different examples of this. So on the back, we're just going to start by graphing points. So you see your first polar points here, A, B, C, D, and E. Okay, notice there's pi's in them because these are angles. Remember that polar points, like I said on the previous page, was set up as r comma theta. So that means in each of these points, the second part is your angle and the first part is your radius. Now, the other different way that I think about these when you are graphing, usually when you're given an xy point, you go the x distance first, side to side, and then the y distance up and down, and then draw your point. I find these easier to identify the angle first for the location and then go out the radius, however it says. So for example, before we do question 1, actually, let's just remember the unit circle stuff and label some of our angles. So we always start on the right here at 0. What was the next angle in the unit circle? Pi over 6. What came next? Pi over 4. And pi over 4 is not drawn in here. It would go right here in the corner. Okay. What would come after pi over 4? Pi over 3. Okay, take a minute. Label around your circle as much as you can remember. All right, so check your angles against the ones that I've labeled in there. Those are the ones that we're going to be working with. So to see just kind of how a first point here works, there are some differences you're going to see between the different points depending on whether things are negative or positive, but we're going to start with a completely positive point. So A is the point 3 comma pi over 3. So like I said, the first thing I identify is the angle. So I go around my circle to pi over 3. Here's pi over 3. Then along that angle, I go out the distance that they say for the radius, counting the rings out. So for that particular one, then, I would be going out 1, 2, 3 rings. Here is the point A. Okay, before I move on to anything with negatives in it, any concerns or questions about that particular one? Because it's a different thought process. All right, so B. B, again, I identify the angle first. So I'm looking at pi over 6 first. Here's pi over 6. Only what's the difference with this one? The negative radius, which means rather than going out towards pi over 6, where am I going to go out for? Backwards, opposite. Okay? So I identify pi over 6, but then I go backwards 4, which means I'm actually going to be going out towards 7 pi over 6. which seems like it's not right, but remember we said points can be named in various ways. So the point B, I could also call that 4, 7 pi over 6 because it's positive 4 in the 7 pi over 6 direction, right? So let's try C then. This time, which one's negative? The angle, right? Since the angle is negative, we know how to do negative angles because we did those with the unit circle, or maybe we remember, we hope. If you do negative angles, instead of going counterclockwise, that just means that you're going to go which way? Clockwise. So where is negative pi over 2 going to land us? At 3 pi over 2, and then I'm going to go positive 2 along that direction here at C. Yes, it could also be named as 2, 3 pi over 2. Yes. D, see if you can graph D and E on your own real quick. All right, so check D and E. Any issues with those two? No? All right, I'm going to erase this quick, and we're going to work with point F in question 2. All right, so part F, or question 2, point F. First, let's graph where point F is. 2 pi over 3, or 4, 2 pi over 3. Hopefully we know that is right there. Now, naming it in different ways. This is what we're practicing on this question. You can have a positive radius and a positive angle. What other kind of combinations can you have for your other answers? Negative, negative is one option. Yep, negative, positive, and positive, negative, right? So see if you can come up with some of those different ways to represent point F, and then we're going to look at a pattern in the angles that you're going to see. Does anyone have a good representation for point F that we haven't seen? They got it. All right, Carson, what do you have for one of these?
First one.
First one.
4, positive 4, negative 5 pi over 3.
Negative 5 pi over 3. I'm going to go with negative 4 pi over 3, and then I agree with you. No, it's good, though. That's good for a first attempt at that one. All right, so if you go negative 4 pi over 3, it's this much backwards, and then 4 in that same direction. That's good. Any other ones? Negative 4, positive 5 pi over 3. That indicates that we go around the circle to 5 pi over 3, which is that line, but then go 4 backwards. Okay, negative, negative is always kind of the hardest one to think about. Negative 4, obviously. And what? Negative pi over 3. Good. Negative pi over 3 sends me backwards to this, and then negative 4 goes back 4 along that same line. Now, everyone look at the angles real quick in those 4 answers. What do you notice about all the angles? All pi over 3s, and out of the pi over 3s that we recognize in the circle, they are all what?
What are they called?
All 4 different ones with the same reference angle, right? So each pi over 3 is showing up one time. It might be positive, it might be negative, but each one shows up one time. It's a good thing to recognize because then it kind of helps you structure your answers, like you know which ones you should have. Okay? We can also name it in a different way where your answers are, if you look at that restriction there, between 2 pi and 4 pi, which really just is, if you remember this phrase from earlier this semester, coterminal angles.
Whoa.
Okay? I know, way back. Coterminal angles simply means that we are adding or subtracting what?
2 pi.
2 pi. Now this one, the reason it only has 2 answers is because if you added 2 pi to the negatives, you'd end up with the positive angles, so you might as well not do that. So we're only going to add 2 pi to the positive angles.
Oh, so you just do...
So 2 pi in terms of thirds is 6 pi over 3.
Yep.
So my first answer is going to be 4, 8 pi over 3. And then this one, if I add 6 pi over 3, the next answer is going to be negative 4, 11 pi over 3. They might, because they're a little chatty over there. All right. I know. Look, you're talking.
Yeah.
Okay, so that one we said we wanted our angles between 2 pi and 4 pi, which we call coterminal angles. We added 2 pi to each of the positive answers to get 2 new angles. Really, that 8 pi over 3 simply means that you'd go around the circle 2 pi and then another 2 pi over 3, which lands you in the same place, right? All right, so now at your tables, we're going to do the same thing with point G. First, let's graph point G. 2.5, negative 3 pi over 4. So where do I go to get to negative 3 pi over 4? Backwards to right about here. And 2.5 in that direction would put me right about here. Right in a nice open space. Yep. All right, so now we want to name point G in the 3 other ways. So far we have the positive, negative, which means we're looking for the positive, positive, negative, positive, and negative, negative. All right, so the positive, positive is 2.5, 5 pi over 4. Good. Negative, positive. Negative 2.5, 5 pi over 4. Or pi over 4, excuse me, not 5 pi. Good. What else? Yes. Negative 2.5, negative 7 pi over 4. And again, you should notice you've used each of the pi over 4s one time in a positive or negative version. The original given and then the 3 other ones. All right. The only other thing we're going to do today is convert between polar and rectangular equations or points right now. We're going to do a little bit with equations next class and basic graphing stuff, and then we will be done with that. So it's really just a couple building blocks that allow you to know what you're talking about for our activity that we're doing at the end. So that's it. You have 2 equations here that you're going to need. In order to convert from from polar points into rectangular, you are going to take the r and multiply it by cosine of the angle to get the x, and you're going to take the r and multiply by the sine of theta to get the y. Anytime it is a point that comes out, or an angle that comes out of your unit circle, you are not going to be using your calculators for this, okay? You should just be using your table and values that you get from that. Now, real quick, before we do these, because your rectangular and your polar point should match up as to where they are. So, real quick, I want to just sketch on this where this point would be. Where's 5 pi over 3 for an angle? Which quadrant? Okay, it's this 4th quadrant right here, but the radius is negative 8. So which way is it going to go? Into which quadrant? The 2nd. So you're going to go backwards 8, and you're going to say, that's kind of my point, negative 8, 5 pi over 3. So when I convert this into a rectangular coordinate, I should have an x and a y that lands me in the 2nd quadrant. It should make sense. If it doesn't, you have done something wrong. And part of this is not just plugging into the formula, but actually making sure it makes sense. Okay? So when I do that, if I do follow the formula, to get my x, I'm going to do negative 8 times the cosine of 5 pi over 3. To get my y, I'm going to do negative 8 times the sine at 5 pi over 3. Now, I told you we're not going to use calculators for this because where can we find the cosine at 5 pi over 3 and the sine at 5 pi over 3? Okay, using pi over 3 in your what? Chart. Okay, so I'm thinking about where that angle is. It's in the 4th quadrant, which changes the positives and negatives. So, to get the x, I'm doing negative 8 times. If I look at my chart at pi over 3, the cosine is 1/2. Is cosine still positive in the 4th quadrant? Yes, cosine is. So I'm going to leave that positive, and that's going to give me what for my x value? Negative 4. To get my y value, I'm going to do negative 8 times the sine at 5 pi over 3. So I think about pi over 3 in my chart. The sine is root 3 over 2 at that reference angle, but in the 4th quadrant, sine is what? Negative. If I multiply those together and keep it in simplified radical form, what is that going to give me for my y? 4 root 3. Now, let's think about that. In terms of an xy point, does it make sense to be going left -4 and up 4 root 3 to get to that point? Yes. So the negative positive should make sense for where this point is. Okay? Same type of thing for the next problem. If I graphed the point to 3 pi over 2, where is 3 pi over 2 in my unit circle? Down here, right? The bottom. 2 along that direction would put it right here. Now, question. If you know where to graph that point, do you actually have to convert it to an x and a y? You should be able to tell from that graph what the x and what the y should be. 0, -2. Right? That's just an xy point right there. Now, let's just make sure it makes sense, though. If I did x equals r times the cosine at 3 pi over 2, what is the cosine at 3 pi over 2? 0, which does work out to 0. And if I did the y is equal to r times the sine at 3 pi over 2, what is the sine at 3 pi over 2? In our chart? At pi over 2, it's 1 because it's at the bottom. It's going to be -1, which gives me -2. Exactly where we said it was graphed here as a xy coordinate. Okay? It should always make sense between the two. Now, you will sometimes get angles where you are not in your unit circle, which is where we use our calculator. Not super difficult to do. So if I take a look at the bottom problem there, first off, what mode should my calculator be in? Radian. How do I know it's not degrees?
I guess the top.
Probably the top ones would give me a hint. Literally, it's here. There is no degree sign. Honestly. Okay? If it's not marked with a degree, you must assume that it's a radian. So to get each of these, I would type them in my calculator, making sure that I am in radian mode. And you're going to get decimals. I typically round to 2 decimal places for each of these. Good. Just because this angle is not something on the unit circle doesn't mean you can't check if this answer makes sense. Think about your unit circle. We said over here 0. We said pi over 2 is about 1.57. Pi is about what? Decimal. 3.14, etc. Now, why do I bring that up? Because where would 3.8 go? It would go somewhere in the third quadrant, out 6. It doesn't really matter where, but the question is, does a negative and a negative for an xy coordinate make sense for that? Yeah. Yes, it does. So see, even if it's a decimal like that, your answer should make sense as to what quadrant you're in. Okay? You can also go the opposite direction. If you're given an xy coordinate, you can find an r and a theta. These formulas will be slightly familiar to you. Okay? The first one, to find your r, you're doing the square root of x squared plus y squared. Anyone remember where we've seen that before? Distance, it's also from vectors. Magnitude of a vector. Okay? And to find an angle, you're going to use the formula tangent of theta is equal to y over x. This is all based off of the fact that basically your x is this side, your y is this side, and your r is your radius from that, and your theta is in here. So basically, if you can make a triangle out of any of these points, you have all 4 pieces within that one triangle. Your x, your y, your r, and your theta. Okay? If you can, you're going to use your chart knowledge to find your angle in terms of radians. And I'll tell you what I mean in just a second with that. The r is very easy to find. If I use that square root of x squared plus y squared, what's that going to give me for an r value? Square root of 2. Do leave that in the simplified radical form. We prefer it that way. To find the angle, I set up tangent of theta is equal to the y over the x. What does that reduce to? -1. Is here's where I pause and ask myself, is this something that I've seen in my chart? Yes. If it is, you can get your radian from your chart, and I do not want a decimal answer for that. If it's not, like you'll see on 9, you'll use your calculator. Either way, you're going to have to use a little bit of common sense here, because tangent equals -1 in 2 different places, right? Where's one place that tangent equals -1? 3 pi over 4 is 1 because tangent's negative in quadrants 2 and 4. The other one is 7 pi over 4. Okay? Now, how do I know which one it is? Based off of the original coordinates. Where is 1, -1? Fourth quadrant. Therefore, which one of these do I use for my angle? This one. Okay, so this, you very much have to think about it and not actually just type stuff into your calculator or put stuff into your formula. To find the correct angle, you really have to think. Okay, we're going to do one with the calculator, and then I am actually going to be done with notes. My point at this point is to get you through a couple days of a little bit of info, but not to load you with homework at the end here. Okay, so you will have time to complete it in class. So if I do the same thing for 9, it's very easy to do the square root of x squared plus y squared to find your r. This works out to a nice even 13. This one, if I set up tangent of theta is equal to the y over the x, the negatives go away. Is that something you've seen in your chart? No, it's not. Okay. Tangent is positive 12 over 5. What am I going to type in my calculator to find that answer? Okay, inverse tangent of 12 over 5. Now, this gives me this answer. A lot of us just write that down. That's my answer. Great. Why is that not the right answer? That's a radian. It doesn't have to have a pi in it. The key is the quadrants. Where? If this is pi over 2, this is pi. This current answer is where? It's actually in the first, because this is about 1.57, right? So I have to think about it in terms of the decimals. So this is actually in here somewhere. Where is my point? The opposite. -5, -12 is over here, right? So to get my answer, I just have to add pi to this because it's in the opposite quadrant. So my angle that I'm actually going to get for this is 4.318-ish. So I'll write this as an ordered pair. 13, 4.318. And this one over here was root 2, 7 pi over 4. We're going to leave it here for today because if I add how to graph shapes in this, our minds will explode on the first day. Yep. So, homework. Page 399, gasp if you will, 1 through 26.